Hi, in this video, we are starting the topic time, distance and speed. This topic is conceptually very simple. The formulas that you need to remember are very few. However, you will find a lot of variation in the types of questions that are asked in this topic. So let's quickly cover the concepts that we need to remember, and after that we will look at a lot of different kinds of questions which are asked in this topic. So the first concept is of speed, and we all know that speed is equal to distance upon time. So if we cover 60 kilometers in 1 hour, then our speed is 60 kilometer per hour. This formula can be readjusted in this way, that is distance is equal to speed into time. So if I am moving at a speed of 10 kilometer per hour for 3 hours, then the distance that I will cover in those 3 hours is 30 kilometers. Again, if we want to find out time and we know distance and speed, we can do that using this formula, time is equal to distance upon speed. So if the distance covered is 40 kilometers and the speed is 20 kilometer per hour, we will take 2 hours to cover this distance. So the formula is simple, speed is equal to distance upon time. If you know any two of these three things, you can find out the third thing. The next thing that we need to know is that we need to focus on is the units of these three things. So distance is usually shown in kilometer or meters. We know that 1 kilometer is 1000 meters. So if we have distance in kilometer, we can easily convert it to meters. And if we have distance in meters, we can easily convert it to kilometers. The second is time. Time can be mentioned in hours, minutes or seconds. Now 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So if we are given hours, we can easily convert to minutes and seconds. If we have it in seconds, we can easily convert it to hours and minutes. Lastly, there is speed, which is usually written in kilometer per hour or meter per second. Now we should know how to convert kilometer per hour to meter per second. So 1 kilometer per hour comes out to be 5 by 18 meter per second. How this is done? So if you are moving at 1 kilometer per hour, that means you are covering 1000 meters in 1 hour. So 1000 meter divided by how many seconds? 1 hour has 60 minutes and each minute has 60 seconds. So 1000 by 3600, that comes out to be 5 by 18 meter per second. So whenever you have value in kilometer per hour, suppose we have a speed of 90 kilometers per hour. To convert this into meter per second, just multiply it with 5 by 18 and the speed will come out to be 5 into 5, 25 meter per second. Similarly, if we have speed in meters per second, so suppose I have a speed of 20 meters per second. To convert it to kilometer per hour, we have to multiply it with 18 by 5. So if it is kilometer per hour 2 meter per second, we multiply it with 5 by 18. If we are moving from meter per second to kilometer per hour, we have to multiply it with 18 by 5. If you do this, you will get an answer of 72 kilometer per hour. So these are the basic concepts that we must know. One is speed is equal to distance upon time, and the other is about the units of distance, time and speed. Now using these concepts, we will be solving all the questions, all the examples and practice questions coming forward. Now let us look at some examples. So these are very simple ones. Suppose that a bus is moving, it has covered 100 kilometers in 4 hours. So what is the speed? Speed is equal to distance upon time. Distance is 100, time is 4. So the speed is 25 kilometers per hour. So notice the units here. Distance was in kilometer, time was in hours. So the speed is in kilometers per hour. Next is we have to find the distance traveled. We know the average speed. Average speed is 50 kilometer per hour. Time taken is 3 hours. So distance is equal to speed into time. So it comes out to be 150 kilometers. Last is we have to find the time taken in hours. But we have distance in kilometers, that is 400 kilometers, and the speed in meter per second. Now, since we want time in hours, it makes sense to convert the speed into kilometers per hour. So we will convert 20 meter per second to kilometers per hour by multiplying it with by 18 by 5, and this comes out to be 72 kilometer per hour. Now time is equal to distance upon speed. So 400 kilometers divided by 72 kilometer per hour. This comes out to be 50 by 9, which is 5.56 approximately, or 5 by 9 hours. So I hope that the concept is clear. Speed is equal to distance upon time. We have used that same formula. In the third part, we also converted speed from one unit to another. Now let's look at a little bit more complicated example. Now this example is related to average speed. So average speed is total distance traveled upon total time taken. So let's take this example. Rahul is covering a distance of 30 km at a speed of 5 km per hour. So from A to B, he has moved at 5 km per hour and the distance is 30 kilometers. Then from this point B, he moves to C, which is at a distance of 20 kilometers. And this he covered at a speed of 10 km per hour. Now we want to find the average speed of Rahul. Now we may think that average speed is simply 5 plus 10 divided by 2, which comes out to be 7.5. But that is not the correct way of finding average speed. Average speed is total distance traveled from A to C divided by the total time taken while moving from A to C. So the total distance traveled is 50 kilometers. We know that 30 kilometer plus 20 kilometer. Now what is the total time taken? From A to B, time taken is 30 kilometer divided by 5. This is 6 hours. Then from B to C, 20 divided by 10. This is 2 hours. So total time taken is 8 hours, 6 plus 2. So average speed is 50 by 8, which is 6.25 kilometer per hour. So you can see that if we just take the average, it will come out to be 7.5, which is not correct. The correct answer is 6.25 kilometer per hour. And for that we have calculated total distance traveled and we have divided it by total time taken. So these are some simple examples to clarify the concept. Now the questions that we will see further are a bit more complicated, but when you analyze the solution that we will tell you, you will see that these are the only concepts being used to solve those problems. Now let's take another example. A girl is going from her home to the market and initially her speed is 2 kilometers per hour, and when she is returning from the market to her home, her speed is 3 kilometers per hour. The total time she is taking in this whole journey of going from home to market and coming back from market to home, she is taking 3 hours for this whole journey. We have to find out the distance between her home and the market. Suppose the distance between her home and the market is x. So the time she will take while moving from her home to the market is d by s, that is distance is x and the speed is 2 kilometers per hour. Now when she is moving from market to home, the time that she will take is distance is x divided by speed is 3. Now we know that in this whole journey she took 3 hours. So x by 2 plus x by 3 is 3 hours. Now we just have to solve this equation to find out the value of x. So 3x plus 2x divided by 6 is equal to 3. And this comes out to be 18 by 5. So x is 3.6. So the distance between her home and the market is 3.6 kilometers. Now let's try out some questions related to time, distance and speed. In this question, there is one athlete who is running from point A to point B. So let's mark point A and point B. Now this first athlete is running at a speed of 10 kilometers per hour. Now a second athlete is running from point B to A at a speed of 15 kilometers per hour. They are crossing each other after 12 minutes. So let's say they meet at some point after 12 minutes. We want to find out after how much time will they cross each other again. Now we will be solving this question in two ways. The first way is of relative speed. When we have two moving objects, instead of looking at both of them from a fixed frame of reference, we can take one of the objects as a frame of reference and look at the entire scenario from that object's point of view. Say, here let us look at what A is seeing. If you look at this situation from the point of view of A, for A, B is coming towards A at a speed of 15 plus 10, which is 25 kilometers per hour. So I hope you understand what is happening here. If you are moving at a speed of 10 and any other object is coming towards you at speed of 15, for you, the object is approaching you at a speed of 25 kilometers per hour. So this is similar to when you are moving in a car. So if the car is moving at a speed of 60 kilometers per hour, then if there is a stationary tree in front of the car, you will feel that the tree is coming towards you at a speed of 60 kilometers per hour. So basically, speed of that object adds to your speed, and that is the relative speed of that object for you. So for A, B is approaching him at a speed of 25 kilometers per hour and B reaches A in 12 minutes. So what is the distance that B covers to reach A? 25 kilometers per hour into 12 minutes. So if you convert 25 kilometers per hour to minutes, it becomes 25 by 60. So this comes out to be 5 kilometers. So distance between A and B is 5 kilometers and B is coming towards A at a speed of 25 kilometers. Now A will now see that B met A. Now B is going to again run away from A. B will travel 5 kilometers back and come back to meet A. So the total distance that B is going to cover now after meeting A is 10 kilometers. And B is running at a speed of 25 km per hour. So the time that B will take to go 5 kilometers and come back 5 kilometers is 10 by 25, which is, and if we want to convert it into minutes, we multiply it with 60. So this is 24 minutes. So I hope you understand what is going on here. We are not looking at this situation from a fixed point of reference. We are looking at the situation from the point of view of A. A sees that B comes and meets him at a speed of 25 km per hour. Then B runs back 5 kilometers and comes back 5 kilometers, and the total time he will take to do this is another 24 minutes. Now let us discuss this in another way. Now again, from A to B, they meet at some point, say C. So combined they have traveled 5 kilometers, which we have seen earlier. Now let's see what is happening here. The first athlete reached point C from A to C, and the second athlete has reached point C from B. They meet at point C. Now the first athlete will move from C to B and then start moving back. The second athlete will move from C to A and then will start moving back, and they both meet at point D. Now let us see the total distance that they both are traveling. First athlete covers C to B and the second athlete covers from C to A. So the total distance that they travel is again L, that is AB. Now to reach D, first athlete will move from B to D and the second athlete will move from A to D. This again totals up to L. So the total distance that they are traveling is 2L this time. In the first run, they covered L distance in 12 minutes. So now when they are covering 2L, we can say that they will cover it in 24 minutes. So whichever approach you find more comfortable, you can go ahead with that. Either you take relative speeds and then solve this question, or you analyze the situation in this way that how much is the total distance being covered, and then you can find the time which will be taken to meet again. Now let's move on to the next problem. In this question, we have a train and a car. Both of them are starting at the same time and they are moving in the same direction. The car is starting its journey from the rear end of the train. The car reaches the front end of the train, comes back to the back end of the train. In the meantime, the train travels a distance of 1 kilometer. If the speed and the length of mail train is 1 kilometer per hour and 1 kilometer respectively, then what is the distance covered by the car? So let's try to understand what is happening in this situation. First, let us see the journey of the train. There is a train moving from a starting point. So let's take a starting point, and there is a 1 kilometer long train, and this train is moving at a speed of 1 kilometer per hour to the right. At the end of this whole situation, the train has moved forward by 1 kilometer. So you can see that the front end of the train, which was at 1 kilometer, that is where the rear end of the train is right now. And we can also see that since the train has moved by 1 kilometer, we can also find out that the whole thing has taken 1 hour, because the speed is 1 kilometer per hour and the distance traveled is 1 kilometer. So this is what we know about the train. Now during this movement of the train, a car started at the same point and at the same time. The car moved forward at certain point of time. Within this 1 hour, at certain point of time, the car was at the front end of the train. So suppose the train was this dotted line at some point in between. At that point, car was at the front end of the train. Then the car turned and went back. At the end of first hour, when the train is in this situation, the car is now at the rear end of the train. So the car is here. So the distance that the car has traveled is, you can see from this situation, till this point it was 1 kilometer, and then the car has traveled some extra distance and came back that extra distance. So let us call that distance as x. So the question asked is, what is the distance covered by the car? Distance covered by the car is 1 kilometer plus 2x. So 1 kilometer plus x, it went forward and it came back x kilometers. So we want to find out this value 1 plus 2x. Now the car has moved 1 plus 2x kilometers in 1 hour. So we have said that the total time taken was 1 hour and the total distance that the car has covered is 1 plus 2x. So now we also know that the speed of the car is also 1 plus 2x kilometers per hour. Right? Now focus on this region. When the car was at the front end of the train, after that the car turned and went back x kilometers. So the car covered x kilometers at the speed of 1 plus 2x, and in the meantime the front end of the train traveled 1 minus x kilometers. So this is 1 minus x kilometers at a speed of 1 kilometer per hour. So the time taken for both of these things is same. While the car was moving from the front end to the rear end, in the same time the front end of the train moved from x position to 1 kilometer position. So we can equate these two times. So the time taken by car is, so the distance covered by car is x at a speed of 1 plus 2x, and the distance covered by train is 1 minus x at a speed of 1 kilometer per hour. Now this becomes x is equal to 1 plus 2x into 1 minus x. So this is 1 plus 2x minus x minus 2x square. We can cut these x's. X square is equal to half. So x is equal to 1 by under root 2. Now the total distance covered by car is 1 plus 2x. Put the value of x here and you will get 1 plus under root 2 kilometers. So that's the second option. So I hope you understand what happened here. So this practice problem was not a very easy problem. I think this is not even medium, this is hard level, and this is the highest level of difficulty that we usually see in the competitive exams. Here the concept was to find out, to equate the time taken by the two objects, and for that we had to understand the situation very clearly. The formula that we have used is still speed is equal to distance upon time only, but what is the situation that is happening, that is what we have to understand. Let us see another type of question that we get in this topic. In this problem, two cyclists are starting from same place to ride in the same direction. The first person is Aflatun, so we will call A, and the second person we will call as B. A is moving at a speed of 8 kilometers per hour. So 12 noon, this person has started moving at 8 kilometers per hour. Person B starts the journey at 2 p.m. after 2 hours, and this person is moving at 10 kilometers per hour. We want to find out at what times the distance between these two people is 5 kilometers. So if you look at this situation, A started 2 hours earlier than B. So let's say at 2 p.m. when B is starting, 2 hours have already passed. So in these 2 hours, A is already 16 kilometers ahead of B. So the distance between A and B is 16 kilometers, and B is moving at 10 kilometers per hour, whereas A is moving at 8 kilometers per hour. Here also, if we look at this situation from the point of view of A, B is coming towards A at a speed of 10 minus 8, 2 kilometers per hour, and the distance between them is 16 kilometers. Now, we want to know after how much time will the distance between them be 5 kilometers. So B has to travel 11 kilometers, and that he has to cover at a speed of 2 kilometers per hour. So we can simply say that the time taken will be 11 by 2, that is 5.5 hours. And right now, if the time was 2 p.m., another 5.5 hours will be taken. So it will be 7:30 p.m. of that same day, 7:30 p.m. So that is one point of time when the distance between them will be 5 kilometers. Now, since B is moving faster, B will overtake A, and again after some time, the distance between them will be 5 kilometers. Now again, the total distance that B has to travel is 16 kilometers plus 5 kilometers, so 21 kilometers at a speed of 2 kilometers per hour. So the time taken will be 10.5 hours. The starting point is 2 p.m. If you add 10.5 hours, it will be 12:30 a.m. of the next day. So 7:30 p.m. of same day and 12:30 a.m. of the next day. Option B. You can see that if we use the concept of relative speed, the question becomes much easier and we can quickly find out the time when they will meet or when there is a certain amount of distance between them. Now let's look at another practice question. This question has two parts. So on this screen we are looking at the first part. Amit is starting a journey and he intends to travel a certain distance at a certain uniform speed. After 1 hour, he has increased his speed by 25%. As a result, in the remaining part of the time that he originally planned for the journey, he could now cover as much distance as he initially thought he would be able to cover. Now, we want to find out what is the total time that he initially expected for the journey. Now, let's try to understand this problem. So, Amit started at some uniform speed that he wanted to move at, say S. And he wanted to cover this journey in time T. So the total distance that he wanted to cover is S into T. But after 1 hour, he increased his speed by 25%. So his speed was 1.25 times S. Now, because he increased his speed, he was able to complete the journey in lesser time. The time that is left from his initially expected time. Now, at a speed of 1.25 s, he could have covered the entire journey of s into t within the remaining time, that is t minus 1. So, what this means is, if the total distance is d, he can cover d in t minus 1 time at a speed of 1.25 s. So, d is also equal to 1.25 s into t minus 1. So, this is all the information that is given to us in this question. Since both of them are the same distances, we can equate them. So, s into t is equal to t minus 1 into 1.25 s. We can cut s also. So, this becomes 0.25 t is equal to 1.25. So, t is equal to 5 hours. So, this t of 5 hours is the total time that he initially expected for the journey. I hope you understand. For 1 hour, he traveled at s speed, and for the remaining 4 hours, he traveled at 1.25 s. The initially expected time for the journey was 5 hours. In the next part of this question, they are telling us that after Amit increased his speed, so for 1 hour he moved for 1 point at s. For the next 4 hours, he was moving at 1.25 s. But now they are saying that if he decided to terminate his journey after covering the distance that he initially intended to cover and not cover the extra distance, what will be the total time taken for the journey? So, initial distance, which was s into t, so st was the distance that he wanted to travel. Now, that is the distance that he is going to travel only. He will not travel for the entire 4 hours at a speed of 1.25 s. So, if he is covering only st, what is the time taken? So, we will take a variable here. Originally, we have found out that t was 5. So, the total distance that he had to travel is 5s. Now, after 1 hour, suppose he walks for x time only. So, for 1 hour, he moves at s speed, and then for x hours, he moves at 1.25 s, and this entire distance is equal to st, which was 5s. Now in this equation, if we cut out all the s's, we can find out x. So x is equal to 4 by 1.25. So this is 3.2. That is 3 hours and 12 minutes. So he has traveled for 1 hour, and after that he takes another 3 hours 12 minutes. So the total time he has taken is 4 hours 12 minutes. So option A. So in this way, you'll have to understand the situation, you have to understand the problem that is given to you, and use the concepts of speed is equal to distance upon time to solve these problems. That's all. See you in the next video.